lecture about how, hey, functions are just like anything else. They're just like variables, or sorry, they're just like values, right? We can pass them into functions, which is, pretty standard. But that also means, well, we're used to passing variables into functions. We're used to doing something with them, and then we're also used to returning something else back to us, right? And so in the last workshop, all the functions that we made, they essentially returned, values. They might have console log something, but they've all been focused on returning other types of values. And now we're just going to go into more depth about, well, if we can pass functions into other functions, there's nothing that prevents us from returning functions out of functions. And so today in this lesson, we're going to talk a lot about why we want to return functions out of other functions. Okay. So here I have a function called returns the string, and all it does is returns I am a string. On line 7, when I invoke, it returns a string. The function returns back I am a string. We capture that value on line 7 and return value, and we console log it out, we get a normal string. So this is how how functions normally work. However, just gonna skip this part. However, there's nothing that prevents us from actually being able to return another function as well, right? So on lines 1 through 3, I create a function called greetMe. All it does is console log out hi. On line 5, I create a function called getGreeter, and all that does is returns the greetMe function. Notice up until line 8, nothing's being run just yet. Okay. The first time any function gets invoked is when we get to line 9, is on the right-hand side of the equal sign. On the right-hand side of the equal sign, we invoke getGreeter. So that takes us to line 5, which then takes us to line 6. Okay. Now, from looking on lines 1 through 3, we know that greetMe is a function. But if you were to only, let's say you had a ton of it, you could only look at lines 5 through 7, you actually have no idea what greetMe is, right? GreetMe could be a number, it could be a string, it could be a boolean, it could be anything. It's only from looking at 1 through 3 that we know that greetMe is a function, okay? And notice a comment there. We're returning the function greetMe. Nowhere up until line 6 do we actually invoke greetMe just yet. And so on line 6, remember, we're returning a variable that points to a value, okay? We didn't do anything with that value. We didn't invoke it, we didn't run it, we didn't do anything. We're just returning that function. And so line 6 returns the greetMe function. So then on line 9, we replace the right-hand side of the equal sign with the greetMe function. And therefore, line 9 becomes letGreeter equals the greetMe function. So when I console log out type of greeter, when I console log out greeter, and more importantly, when I invoke greeter, in all 3 instances, I am basically looking at type of greetMe. We're console logging out greetMe itself. And then lastly, we're invoking greetMe. So on line 11, what type is greeter? Well, the type is a function. What happens when we console log out a function? You saw in the previous workshop, when we console log out a function, JavaScript presents it in this kind of way. Once again, let me just reiterate, the colon and the brackets do not mean that this is an object or an array. This is just literally how JavaScript chooses to print out functions. And then lastly, on line 13, when we invoke the greetMe function, that is identical, or that is the same as us invoking, on line 13, when we invoke the greeter function, that is the same as us invoking the greetMe function. I think someone's mic is still on. I hear some rustling in the back. So if you just turn it off, that'd be great. Thank you. Okay, so right now, all we're looking at here is just we are treating the greetMe function as if it was any other data type, right? In the last slides, we saw us pass the function into another function. Now we're returning a function out of another function. The difference between that and line 6 on this slide, so everything on this slide is the same as the previous slide, except now on line 6, rather than returning greetMe as a function, on line 6 now, we're actually invoking greetMe first. We're saying greetMe invoked, and then returning whatever that function returns. One thing I mentioned in the very, very early portion of our curriculum was all JavaScript functions are going to return something, okay? Every JavaScript function always returns something. If you say return blank, it will return the blank. It will return whatever it is that you tell it to return. If you don't tell it to return anything, it will by default return undefined. Okay. So on line 6, when we look at the greetMe function, what happens when We get to line 9. On the right hand side of the equal sign, we invoke getGreeter. That takes us to line 5, which takes us to line 6. On line 6, it says invoke the greetMe function. We invoke the greetMe function on line 1. Line 2, console logs out hi. Line 3, the function ends. At that point, we say, hey, this function didn't return anything, or we didn't tell it to return anything. So therefore, that function is going to return undefined. Okay, and so line 6 becomes return undefined. And so when we work our way back to line 9 now, the right-hand side of the equal sign becomes undefined. And line 9 becomes let greeter equals undefined. So therefore, when we console log out type of greeter, we get back, or sorry, we get hi when we invoke greetMe from line 6. But on the second printout, that's what type of greeter is. It's undefined. When we console log out undefined, it's still undefined. And on line 13, when we try invoking undefined, we get an error that says greeter is not a function. You tried to invoke something that is not invocable, right? You tried to invoke something that's not a function. So it's super critical on line 6 there. When you return a function, that you're very clear in your mind. Are you returning the function, or are you returning what you get after you run the function? Okay, those two are very, very different things, and it's not the kind of thing where you can just kind of run it and hope for the best. Like, you need to be very, very precise there in what you're returning. Similarly, if we kind of take this example a little bit further now, on line, this is still once again very similar to the previous slide, except now on line 3 through 5, we actually create this function called greetMe. It's created within the getGreeter function from lines 1 through 8. Okay, so now when I look at this on line 10, when I say let greeter equals getGreeter, well, when I invoke getGreeter, that takes me to line 1, then takes me to lines 2, 3, 4, 5, 6. Nothing runs yet. On line 7, it says return greetMe. Well, once again, on line 7, what's greetMe? greetMe is just a variable. What does it point to? It points to the function. Do we run the function? No, because we don't see greetMe with an open and closed parentheses after it, which means invoke the function. We're just treating it as if it was any other value. In this case, it's just a function. And so on line 10, on the right-hand side of the equal sign, getGreeter becomes this function called greetMe. So greeter, so therefore line 10 simplifies to let greeter equals the greetMe function. And on line 11, when we invoke greeter, that is the same as us invoking greetMe. And then last but not least, this is something that we talked about with the anonymous functions too. Here we use an arrow syntax. You can also use anonymous functions too. But the idea is when you return a function, just like how in the previous example, when we just defined a function on the spot before we passed it into the for each loop, this is the same idea. We're going to say return and then just write a function and return it right away too. So we don't always have to store a function in a variable and then return the variable. We could just return the function directly. Okay. If the arrow syntax here confuses you, don't worry too much about it. You could write it traditionally too. You just say return function keyword, open close parentheses, and then the curly braces to denote the body of the function. Okay, so it doesn't change anything. The point here is just that you can return anonymous functions as well. And then lastly, because we are returning functions that are fully operational or just like the original, if our function took in any arguments, like in this case on line 3, here we're returning an anonymous function that takes in a name parameter. Well, on line 8, after I run getGreeter, that returns back a function, so greeter becomes the anonymous function, and therefore on line 10, when I invoke greeter, I just pass something in, right? I treat greeter as if it was the anonymous function, so if that function is expecting me to give it a value, give it a name, then I will give it a name when I run it. So now I have greeter, I can do Marie, Rosalind, and once again, if a function expects an argument, but you don't pass anything in, then by default, within the context of that function, that value becomes undefined. And so therefore on line 12, if you don't pass anything in, it will say hi, comma, undefined, because now name is undefined. Any questions so far? Are we good? Awesome. Okay, let's keep it moving then. So now we're going to talk about the title slide, closure. What is closure? So before we talk about closure, let's go back and revisit what we learned about scope. Seems like a while ago, right? But it was only just last week. What's closure? Or sorry, what's scope? Remember, scope is something that works in one direction, right? Scope determines the boundaries of where you are able to access certain variables. For us, scope can be determined, or sorry, for us, scope is determined based on the curly braces. And if you use let as your way to create variables, scope can be created based on functions, the curly braces associated with functions, and then but also the ones with loops, right? Like for loops or while loops or if statements. Those all create their own senses of scope. Remember, with scope, if you create a variable inside a scope, anyone within your scope can use that variable. Okay, and you also have access to your parent scope, your parent's parent scope. Basically, whatever scope you are in, you are always able to look outwards, right? You're able to look outwards more and more scope levels until you reach the global scope, at which point you will stop. Okay. The limitation of scope, however, is that you cannot look in anyone else's scope, right? So if in your scope someone else makes a function and they put their own stuff in there, you can't look into what we call a child scope, right? You cannot look into a scope that was created inside of you. Similarly, you cannot look in any scopes that are parallel to you, what we call sibling scopes, right? So once again, you are only able to look in your own scope, your parent scope, outer, all the way until you get to the global scope. Okay, so here in the greeter function, I create a variable called name, assign the value of Marie. On line 8, I create a function called says hi, and the value of it is a function, and the function console logs out hi, comma name. And on line 11, when I invoke says hi, I'm invoking the function on lines 8 through 10. In the function, when it invokes, it console logs out hi, comma name. The first thing JavaScript will do is it'll say, oh great, you're using a name variable. Is there a name variable in the says hi function scope? It looks through lines 8 through 10 and says, nope, there's no name variable there. So then it'll say, great, is there a variable called name in your parent scope? And in the greeter function, there is a variable called name. It's equal to Marie. So when we invoke greeter, we invoke greeter. It takes us from line 6, 7, 8, 9, 10, all the way to line 11. Line 11 takes us back to line 8, 9. On line 9, we console log out hi Marie. Okay, this is how scope works, right? On line 9, we always look in our own scope first. If it doesn't have it, then we look outwards. We look to our parent scope. Closure then is this phenomenon that occurs that the inner function can still access defined in the outer functions even after the outer function is finished running. That's a lot of words and it's pretty heady to understand. I think it's probably better for us to see an example. This is a previous function, right? We haven't changed anything here. Except notice how the one big thing that is different now is rather than running the function that we create on lines 8 through 10, we return it. Okay, so here if I was to run this page of code, right, I get to line 13, right? So lines 1 through 11 just defines a function. We're not running anything just yet. I get to line 13. Now on the right hand of the equal sign, there's a getGreeter function. Okay, that means we invoke getGreeter. That takes us back to line 1. Which takes us to line 2, and we console log out getGreeter is running. That takes us to line 3. On line 4, we create a variable called name equals Marie. On line 6, we invoke this function. We invoke the console. Or sorry, not invoke. Sorry, we run the console log getGreeter is finishing. And then on line 8, we return this anonymous function that console logs out hi, comma name. Okay. So on line 13, the right hand side of the equal sign becomes the anonymous function. So greeter is now the anonymous function. So now on line 13, it becomes let greeter equal the anonymous function that we created and returned on lines 8 through 10. Now, when we invoke greeter, we take us back to line 8, then to line 9, which console logs out hi Marie. Okay. So what's happening here? Well, so first of all, we see the getGreeter is running, getGreeter is finishing, right? That makes sense. That comes from our initial run of the getGreeter function. On line 14, when we invoke greeter, we get back hi Marie. Why is that so strange, or why should that seem strange to us? Well, on line 14, if you notice, the greeter is once again the anonymous function we created on lines 8 through 10. But when we invoke greeter, we're able to figure out what the variable name is. Okay? The issue is greeter on line 14 exists outside the scope of the getGreeter function. That only exists on lines 1 through 11. So if we're outside of the getGreeter function, how are we able to access the name variable that was created inside the scope of what we call a child function, right? Get greeter, on line 14, greeter is on the global scope. How is it able to access a variable inside the scope of one's functions? And so this is kind of fundamentally the key idea of closure, which is that the scope of a function is determined based on where it was created, not where it is used. Okay? Say that one more time. The scope of a function is based on where it was created, not where it is used. On line 8 through 10, I created this function, right? And that function scope was set based on where it was created. So that function scope will forever be based on lines 8 through 10. I could use that function anywhere else, even outside of the function that it was created in. The scope for that function will not change. On line 14, greeter's value is still the anonymous function, and therefore when we run that anonymous function, it is as if we are running it from where it was created on lines 8 through 10. Okay, so whenever we run greeter, it's almost like we have access to the same scope that the function had when it was created, not based on where it is currently being run. Okay, I have a question here. It is similar to reference versus pass by values, pass by reference. No, because pass by reference is because scope isn't really related to pass by reference or pass by value, right? Scope is almost like a boundary, like an idea that we establish a boundary. All this is saying is we're not trying to quote unquote copy. Oh, yeah, it's not really a reference because like yes, you're right that like greeter is referring to this function exactly. But the question isn't like which version of this function we're looking at. That's what pass by reference versus value is doing. What we're really asking is, hey, which variables does this function, like which scopes does this function have access to? And the answer is this function has the same access to the same scopes that it had when it was created. And it was created here, and so therefore it has access to all of this as a scope, no matter where this function is being used. If you notice, we only have 3 more slides, so this is pretty much the crux of this lesson here. So I'll pause and take questions before we go any further. All right, does this make sense to folks? Are there any questions about what I just said?
Yeah, can I ask a quick question?
Absolutely. Let's have a pause.
This might be pretty basic, but can you explain again why the greeter invocation on line 14 is referring to the function on line 8 instead of like just the get greeter function?
Yeah, because here on line 13, when you invoke get greeter, we invoke get greeter, right? So now this becomes whatever get greeter returns. Okay? So
okay.
this is the same as us saying now let greeter equal this anonymous function from up here. This is not repo, so it's hard to type, but hopefully you get the idea.
Got it. Thank you.
Yep. That's why like always be aware of whether or not you're looking at a function. This is a function. This is what happens after you run the function. Very, very different. Okay. Any other questions? Okay. Well, we'll go through a few more examples. And we're just kind of building on top of this concept now, right? This next example base says, well, what if greeter takes a parameter? Nothing really changes, right? Remember, a parameter is a variable that exists only inside the function scope in which it was created, right? So here on line 2, you'll notice that getGreeter takes in a name. So everywhere within this function, we now have access to this variable called name. And so on line 3, when I make an anonymous function that returns hi name, on line 9, when I run that function, well, based on where the function was created, which was lines 3 through 5, does that scope have access to a variable called name? Yep, that variable called name came from a parameter. So therefore, on line 8, when I initially ran greeter with the name Rosalind, well, in that case, the function that got returned, the anonymous function that got returned, that's now the greeter variable, and that function will always have name equals Rosalind in its scope. Okay. One of the things that you can think about that I tell folks if it helps visually or mentally to think about is you can almost imagine here there being this line of saying let name equals Rosalind or whatever it is that you passed in. Okay, I put a comment here because we never see this line, but that's effectively what this is doing, right? In this, sorry, yep, inside that function get greeter, we may name a parameter. So basically, when we pass in Rosalind, that in that case name will be Rosalind, and when we do a return function, that function will forever think. It's almost like imprinting, right? Like that function will forever think that the variable name stands for Rosalind. And then lastly is what happens if both names take parameters? Well, same idea, right? Name one is part of the scope. Okay, name one is part of the scope. And so here on line 8, you see us say let greeter equal get greeter Marie. So why is this important? Well, now when we invoke get greeter, name one is equal to Marie, and we return a function that will take in its own name and will say hi Marie meet whoever it is that we pass in. Okay. Ta-da! So hi Marie meet Rosalind because we invoke get greeter was Marie, and then in the function that gets returned, we invoke that, and that expects a name2 variable, so we pass in Rosalind, so it says hi Marie meet Rosalind, right? When we invoke the greeter on line 9, we're essentially invoking the anonymous function on lines 3 through 5. If we go to line 4, it says console log hi name 1. Well, where does it get name 1 from? It doesn't have a name 1 in its own scope, so then it goes to its parent scope, which is get greeter. It finds name 1 there, so it'll say hi Marie, and then comma meet name 2. Does it have a name 2 variable in its own scope? Yep, it was just passed in, and we passed in Rosalind, so that's why it says hi Marie meet Rosalind. Why would we do this, right? And I think that's a question that I'm probably going to get eventually. So why do this? And the reason why we want to do this is because if you really think about what we're saying here, is within the function, I can create all of these variables. But sometimes I actually want other people to have access to those variables. How do I do that, right? By default, JavaScript does not let anyone access my variables unless either 1, I make it global, right? Or 2, in this case, what I'm doing is I am actually able to export. I'm actually able to send off almost like a representative, like I'm able to send off like a function that is able to access the functions that I want other people to have access to. Okay, so why is that important? Well, here on line 7 through 8, notice how I've now created. On line 7, I said let introduce Marie to this variable. It's equal to get greeter, and we pass in the string Marie. Okay, remember, get greeter is going to return to us an anonymous function, and we're going to store that anonymous function in introduce Marie to. And the important thing here is, as far as introduce Marie to is concerned, as far as that anonymous function is concerned, name 1 is equal to Marie. Okay, that's all it knows. Name 1 is Marie. On line 8, we then write let introduce Rosalind to, and we run get greeter again, and we pass in Rosalind. Okay, so at this point we are running another instance of get greeter, and now we're saying, hey, name 1 is equal to Rosalind, and get greeter now is going to return another anonymous function, and we're going to store that anonymous function in the variable introduce Rosalind to. And as far as that anonymous function is concerned, name 1 is always going to be Rosalind. Okay. Just so we're clear, line 7 and line 8, they both store a different copy of the same anonymous function, right? Because they were created separately. This is almost like me saying like, hey, let x equals this array 4 comma 5. Let y equals this array 4 comma 5. Okay, even though the arrays may have the same value or they may look the same, they're inherently different, right? What I do to one will not affect the other. Same idea here. Even though introduce Marie 2 and introduce Rosalind 2 are the same anonymous function, they're copies of each other. The difference there is introduce Marie 2, as far as that function is concerned, name 1 is equal to Marie, and for the other one, the name 1 is equal to Rosalind. Okay, so now if I want to introduce Marie to Dorothy, introduce Marie to Albert, or introduce Rosalind to Barbara, introduce Rosalind to Isaac, this now all kind of works for me out of box. And so the reason why, once again, why Clojure is so important is because one, it allows us to give other people access to variables that I want them to have access to. Okay, it lets me almost export all of these variables that up until now was only able to exist in my own scope. And the reason why that's important is because, hey, I may want to change these values at given instances. Okay, and line 7 through 8 is a great example, right? I may want to create a bunch of functions that think name 1 is Marie, and I may want to create a bunch of functions that think name 1 is Rosalind. And after I create these functions, that's fixed, right? As far as that function is concerned, name 1 is Marie, and then name 1 is Rosalind for the latter function. Okay, so now my function is actually a lot more flexible. Okay, now, for example, on line 10, if I know that I only want to introduce Marie to people, I can create this function called introduce Marie to and only pass in the second name that it wants to greet. Now, could I have done this where I pass in both name 1 and name 2 into the same function? The answer is yes. In this case, it will work and it probably wouldn't be that much harder. But the point here is, once again, is now we kind of have this additional tool at our disposal, which is I am able to give almost, you can think of it as we can give outsiders access to our, I hate using this word because it means something very different in other languages, but it gives outsiders access to our private variables, right? Variables that used to only exist for us, now we can give other people access to. Okay, and that's pretty much it. So, I mean, I'll go back to the previous slide here, oh, no, this one, and I will open up to questions.
Do you mind re-explaining the last two phrases that you said about giving access to private variables?
Yeah, sorry. Private variables means something very different in other languages. So it's, I mean it as more of like a descriptive term. It's all I'm trying to say is here, right? In this case, if in my, let's say, let's put ourselves in the shoes of the getGreeter function. I create this variable called let name equals Marie. Okay, no one else has access to the Marie variable, right? Like if you're outside of this function, you cannot get access to this name variable because it's in my scope and you don't have access to it. But by using this function that returns console log out hi comma name, you are now able to get access to this name variable, right? Like we're able to have someone from the outside be able to use it. So let's let me just copy this over and okay, so let's go here. All right. Oh gosh, it put parentheses noxious question marks all the time.
Yeah, it was just confusing because you said it in the when you were on the slide with the function that did not have a private variable.
Oh yes, yes. Sorry about that. Yeah, sorry. That was more of like a summary highlight of this. But once again, here, if I just do a console.logout name, JavaScript is going to give me an error. It'll say, "Yep, name is not defined," or "name does not exist," because I can't look in from here. I can't look inside the function of getGreeter. But in this case, if I comment this out and I run the code as we had it before, now I actually, even though I'm outside, right? I'm outside of the getGreeter function. I'm able to console log out hi and then Marie, right? Or I can even say, new name, hi new name, comma name, and here I can do getGreeter. I'll do David, and now it says hi David Marie. Right? It's almost like even though I'm outside of this function, now I can have access to and make use of this function or this variable here.
Awesome, thank you.
Yep. I'll put it up here in case anyone wants to follow along for anything else. Yeah, any other questions?
Would this be a good time to ask questions about the last the last workshop?
Not yet. So for this afternoon set of workshops, what I'll probably have